So there's a data definition and two functions. One function, nextCat, can take us from one cat to the next cat. In other words, it can advance the cat's x position by 3 each time, 0, 3, 6, and so on. The other function can take us from a cat to an image of the cat. In other words, the image of the cat at the appropriate position on the background, called MTS. Now we need to understand how those two functions need to dance together in order for the cat to move across the screen the way we want it to. Suppose the cat starts at 0. We need to call renderCat to get the appropriate image and display that. Then we need to call nextCat with 0 to get 3. Then we need to call renderCat with 3 to get the image and display it. Then nextCat with 3 to get 6. Then renderCat we call with 6 to get the next image and display that. Then we call nextCat with 6 to get 9. Then renderCat with 9 to get the image and display it. NextCat with 9 to get 12. RenderCat with 12. NextCat with 12, 15, and so on and so on and so on. And all we need to do is do that 28 times a second, which I can't talk that fast. To do that, to wire renderCat and nextCat together that way, Dr. Racket gives us a special expression called a Big Bang expression. And here's an example of how we would use Big Bang to make the cat walk. The first argument to Big Bang is an expression that evaluates to what Big Bang calls the initial world state, the initial state of this whole interactive world. In this case, the state of the interactive world is represented by the cat type, and so we're going to give it an expression that produces a cat. So 0 is the initial position of the cat. After its first argument, Big Bang takes a number of options, and it takes so many that the way it does it is to take them by name. That way you can give it only the options you want to give it each time. The way to read this first option is it says each time the clock ticks, call the nextCat function, pass it as an argument the current state of the world, and it will give you back the next state of the world. Because in this particular Big Bang expression, the state of the world is represented by cat, I've put a comment here saying that the type of the first argument to Big Bang in this case is cat, and another comment here that says that the signature of the nextCat function is that it consumes cat and produces cat. The second option to Big Bang in this case is called toDraw. And you should read this use of toDraw as saying that what Big Bang is going to do is on each clock tick, it's going to call renderCat, passing renderCat as its first argument the current world state, in other words, a cat, and renderCat will produce an image, and Big Bang will display that image. And I've made a note here off to the side that the signature of renderCat is that it consumes cat and produces image. So what Big Bang is doing for us is it's taking all the little pieces of our world, the initial world state, the tick function, the draw function, and it's combining all those pieces together to get a world. Do you see the joke behind the name now? It squeezes the pieces together. Big Bang. It produces a world. Whether you like that joke about the name or not, that is the name. I didn't come up with it. One other point to make about Big Bang is that it's what computer scientists like to call polymorphic. It can work for any type of world state. So Big Bang doesn't just work with cats. It can work for example, if you have a interactive world program that has to do with fireworks, then the world state could be firework. Or if you have an interactive program that has to do with lots of fireworks, then the world state could be list of firework. The world state can be anything you want to be. So actually here where we've noted cat and cat to cat and cat to image, as far as Big Bang's concerned, it can be anything. So really it could be X, X to X, and X to image. All Big Bang wants is for you to give it an initial world state. And then for onTick, you've got to give it a function that consumes a world state of that type and produces a world state of that type. And then for toDraw, you have to give it a function that consumes a world state of that type, whatever it is, and produces image. The key thing is, in any one use of Big Bang, all the X's have to be the same type. They all have to be consistent. That's what matters to Big Bang. So there's Big Bang. It's without a doubt the most complicated single primitive we're going to use this term. It's a user interface framework, and user interface frameworks, in other words, tools that integrate a bunch of functionality together to get an entire user interface. User interface frameworks are always somewhat complicated. This one is simpler than most. Don't worry about it. We're going to spend the whole week on it. You'll get a lot more chances at it. But the basic thing to understand is this picture up here in the upper right, that's what Big Bang is doing. It's starting with an initial world state, and then it's coordinating calling functions like render cat and next cat to produce the combined behavior of the interactive program that we want to have. We'll also see starting in the next video that there's more options. So for example, Big Bang has an option called onKey. And you can imagine that the way that works is onKey wants a function that it will call when a key is pressed on the keyboard. And that function should process the key properly and produce the next world state. What we'll also see in the next video is we're going to introduce a design recipe for designing interactive programs using Big Bang, and that design recipe is going to help make it a lot easier to write programs that use Big Bang.